All right, let's look over this practice test here. So in question 1, we want to know what value of A would give us an upward facing graph. So that means we know that A has to be positive because positives open upwards and negatives open downwards. So being that this is multiple choice, I already know that those two options are out. Then, because I want it to be wider, and I want it to be wider than 1x squared, I know that smaller / closer to 0 numbers are wider. So I know that 2, for instance, 2 is going to be skinny or skinnier. 0.5 or 1/2, that's going to be wide. So that would be our wider graph again. The bigger the number, the skinnier it is. Bigger equals skinnier. So yeah, two pieces there. Positives open up versus the negatives that open down, and then bigger equals skinnier, closer to 0 equals wider. All right. Using the same knowledge here, how are we gonna answer this? How are we comparing negative 4x squared to x squared? So this is G, this is F. So what would we know about G? Well, G would open that direction versus F that would open up. G is going to be a little bit skinnier than F because it's negative 4. It's a larger absolute value. So G is wider than F. That's not true. F and G open in the same direction. That's not true. Now, having the same vertex, they open in different directions, but there's none of this BX plus C stuff behind either of these. And so because there's no BX or C, there's no left and right, and there's no up and down either. So we actually would see graphs that look like this. Here would be x squared. It would come down, have a vertex of 0, 0. And here would be G. And again, it's a little bit skinnier. Let me change color there. But still has a vertex of 0, 0. And has the same axis of symmetry, which would be x equals 0. So those two things would be true for those two functions. All right, this one, what values of x is the function increasing and when is it decreasing? So as we look at our table, we can see that 12 to 6 to 4, this is my chunk where I'm decreasing. And then 4 to 6 to 12, this is my chunk that I'm increasing. So one of the things I got to do is figure out where does it stop going down and start coming back up. So I could plot this really quick. Negative 3, 12 would be somewhere up there. Negative 2, 6, 1, 4, and then 0 goes back up to 6. So you can see that's where it flips over. So there's my axis of symmetry was sitting at negative 1. And so that's going to tell me that negative 1 is going to be my number where these two things are going to happen, where we're going to change direction. Now, where are we increasing? We're increasing when the values of x are greater than negative 1, right? 0, 1, 2, so on and so forth. Where are they decreasing? For those values that are less. Oops, not lesser, that's not a word. Less than negative 1. So again, we need to look for two things here. Is it increasing then decreasing, or is it decreasing then increasing, such as this one? And where does it flip over? Where does it change? Where is that axis of symmetry? Where is that vertex? In this case, the table would show us that it happened to be at -1. So that's the value that goes in right there. All right, what value of b would you expect to see in the equation for the pictured graph? Again, we know what the vertex is. It's at the x value of the vertex is -2. So when we use our equation for the x value of the vertex, which is -b over 2a, we know the result needs to be -2. So that's our setup there. Now, what we also know is that my a value is 1. Whoops. So I know that I have -b over 2 equals -2. So the question here is, what does this b value need to be to make that true? Well, I know that if this were just, whoops, let's go back there. If this is now just a 2 value, oh, no, that's not right. Sorry, wrong number. We know that this is 4, and we take -4 over 2, we would get -2, and that's what we want. So my b value needs to be 4. Now be careful with that sign. Remember, you're going to have that negative in the equation. So we did want -4 up top, but because I already have a negative sign there, I didn't need a -4, I actually just needed a +4 as my b value. If we needed to have a positive up top, then I would need a negative number, because a negative and a negative will get me back to positive. All right, number 5 is our velocity question. Again, we have our basic equation, which is h of t equals -16, and that's for gravity, t squared plus v sub 0 t, and this is initial velocity, and then plus h sub 0, and that's my initial height. So those are the two pieces in our function that we need to sub in. I need to know what this is and what this is. We have my initial height here and my initial velocity there. So we just simply rewrite this as h sub t equals -16t squared plus, now we'll do the velocity, which is 64. Don't forget there's a t still behind it. And then we'll do h sub 0, which is my initial height, which is 8. Once I have that, now I can do the maximum height by using my max equation, which is -b over 2a. We know that the b value is 64, so we're going to go -64 over 2 times the a value, which is -16. We start to simplify that. We get -64 over -32, which is +2, and that's seconds. So maximum height for the cat occurs at 2 seconds. We've got that part. Now that becomes our t value. So we're going to go to the equation. We're going to go -16 times 2 squared plus 64 times 2 plus 8. Just remember when you're doing this, that this part gets done first. So this is -16 times 4 plus 128 plus 8. -64 times 4 is negative, I have to go over here, -256. Oh, what did I do? -16 times 4, sorry, is -64. Plus 128 plus 8 Negative 64 plus 128 plus 8 is 72. So we've got 72 feet in the air, 2 seconds after he jumps. For the function negative 3 x plus 4 squared plus 2, find the following. Again, this is in vertex form, which means finding the vertex is pretty straightforward. This is going to be my x value, but opposite of the sign, this is my y value. So that's where I'm going to start. I'm going to go down here and say my vertex is actually just negative 4, 2. Again, that piece goes there, that piece goes there. If that's my vertex, that's my axis of symmetry. Because again, these two are always going to match. The y-intercept piece, without going to standard form, which we do need to do in D, so we could jump to that. But if you don't actually have to do the standard form, or if you want to double check, the y-intercept is going to be found by taking the x value and replacing it with 0. So 0 plus 4 is 4, and 4, so 4 would be here. Then we would square 4, which is 16. So we'd have negative 3 times 16 plus 2. Negative 3 times 16 is negative 48. And negative 48 plus 2 is negative 46. So I currently think it's negative 46. Now, we're going to double check that here in a second because we'll do standard form. So to do standard form, what I need to do is I need to first expand this part out. So I will show that using a box. X plus 4, that's x squared, 4x, 4x, and 16. Which means I've got negative 3 times x squared plus 8x plus 16. And then plus 2. So now it's a matter of just distributing that negative through the parentheses. Negative 3x squared minus 24x minus 48, and then plus 2, and then we can combine like terms here, giving us negative 3x squared minus 24x minus 46. So that would be my function. I could put f of x in front of this and be done with it. Now, I mentioned we're going to find the y-intercept here. Remember, the y-intercept in standard form is your c value. You can see we actually have a match here, so verifies that we've done things correct there because we've got the same c value. Now, as far as graphing this thing goes, again, a lot of this is already done. We know what the vertex is. It's negative 4, negative 2. We know what the y-intercept is. It's negative 46. We know what the axis of symmetry is. And I draw that in because if I know that this point here is 4 to the right, I'm going to go 4 to the left. 1, 2, 3, 4, and use symmetry. So I've got an extra point that I graphed that I didn't even have to do anything for. I just used symmetry. Now we do need one more point to do this, most likely, so I'm going to sub in negative 2 into the equation. And again, we can sub negative 2 into the standard form equation or into the vertex form equation. Let's use the vertex form equation. So we're going to go negative 3. Now again, we want the x value to be negative 2 from here. Negative 2 plus 4 in the parentheses is 2. 2 squared is 4. Negative 3 times 4 is negative 12. Negative 12 plus 2 is negative 10. That's my y value. So when x is negative 2, y equals negative 10. You can put another dot there. And again, with symmetry, if I'm 2 to the right, I can go 2 to the left and be in the same spot. And now I've got 5 points. I've got enough to sketch this thing as best I can. All right, let's look at 7 here. This one is in standard form, and so the y-intercept is where we can actually start this conversation, because we know the y-intercept is going to be negative 5, or in coordinate form 0, negative 5. I'm actually going to find the vertex before I find the axis of symmetry, so I guess it doesn't matter. Either way, we're going to do negative b over 2a to find that value. So I've got negative 4, because that's my b value. My b value is negative 4, so negative 4 on top of 2 times my a value, which is 2. That gives me negative 4, which is 4 over 4, which is 1. Tells me that my axis of symmetry is x equals 1, and it tells me that my x value of my vertex is also 1. To find my y value, I'm going to sub 1 into the function for x. Let's see what happens. 1 squared is 1, and 1 times 2 is 2. 4 times 1 is 4, so 2 minus 4 minus 5. 2 minus 4 is negative 2. Negative 2 minus 5 is negative 7. So that should be our vertex, 1, negative 7, which would also be our axis of symmetry. We know the y-intercept is negative 5. And I can use symmetry to put one more point in there. And now we just need one more point. We could use negative 1 or 3. We'd get the same results, whichever one you're more comfortable using. If we go back to the equation, 2, I'm going to use 3. 2 times 3 squared minus 4 times 3 minus 5. 3 squared is 9. 9 times 2 is 18. 4 times 3 is 12. 18 minus 12 is 6. 6 minus 5 is 1. So 3, 1. Again, we can use that symmetry to get that next value, and we've got the makings of a quadratic that looks like that. Number 8, you're just going to use your calculator to figure out what that rule is. All right, so we're going to go stat, enter. This is going to be my L1. This is going to be my L2. I told you it's quadratic, so then it's just a matter of going stat, over to calc, and then choosing option 5, which is quad reg. You'll get your A value, your B value, and your C value, which then you can sub in for A, for B, and for C. Just make sure you look to see what you're supposed to round to, because they're always going to have more than enough decimals in the calculator. All right. Last questions deal with, is it quadratic, linear, or exponential? We do that by looking first at our first differences. So negative 7 to negative 4 is actually plus 3. Negative 4 to negative 1 is plus 3. Negative 1 to 2 is plus 3. And 2 to 5 is plus 3. So we can stop there. We've got first differences that are the same. That makes it linear. In your explanation, something about first differences. Let me erase that. Let's try that again. My first differences are the same or constant, something along those lines, talking about first differences. Number 2, Does the table represent linear, exponential, or quadratic? Again, we'll do the same thing. Let's look at our first differences. 2 to 4 is plus 2, 4 to 8 is plus 4, 8 to 16 is plus 8, and 16 to 32 is plus 16. So first differences aren't consistent, it's not linear. Now let's look at the second differences. 2 to 4 is plus 2, 4 to 8 is plus 4, 8 to 16 is plus 8. Our second differences are not constant. It's not quadratic. So then we go, is it exponential? Was there a common ratio? Four divided by 2 equals 2. 8 divided by 4 equals 2. 16 divided by 8 is 2. And 32 divided by 16 is also 2. So there is a common ratio, it is exponential, and that's how we know. So I could say something like common ratio of 2. And then the last one, let's try first differences. 6 to 0 is negative 6. 0 to negative 4 is negative 4. Negative 4 to negative 6 is negative 2. Negative 6 to negative 6 is 0. Negative 6 to 4 is plus 2. Negative 4 to 0 is plus 4. And 0 to 6 is plus 6. Again, notice that I put the signs in there because that becomes important. How far apart are the two numbers but going in the same direction? Now, first differences are obviously not the same. Those are all over the place. How about second differences? Negative 6 to negative 4 is plus 2. Negative 4 to negative 2 is plus 2. Negative 2 to 0 is plus 2. 0 to 2 is plus 2. 2 to 4 is plus 2. And 4 to 6 is plus 2. So because we've got those values all the same, and those are in our second differences, then we say that this thing is quadratic, and then we say that it's quadratic because second differences are constant. All right, that's it.